Question 5, a bit of a mean question actually. It did rely on a little bit of knowledge from chapter 18.7, which of course we haven't yet looked at. There is an equation in chapter 18.7 for gravitational potential energy, and that is something like this, where G is the gravitational constant, M is the mass of one planet, M2 is the mass of another planet, and R is the distance between it. So there's a gravitational potential energy between two objects with a mass given the distance apart. Then, because it's a type of energy, that can then be put equivalent to kinetic energy, and that then links to the equation that you needed to use on question number 5, the Schwarzschild radius. I mean, you don't need to know the derivation there, but you can work it out that if you rearrange it, change the V for a C, then it will turn into RS equals 2gm over c squared. So you don't need to know this, but there's the derivation, which once things cancel through, you end up with a very similar form. However, I'm not really sure that the problem was from the equation as such. It was more the notations that were used and the values that you needed to use in order to get to the answer for question 5. So there were some key things that you needed to be aware of. There was another equation for gravitational field strength, which you may not have seen, so apologies that if that left you a little bit stumped. You also had this here, which is the mass of the Sun, gravitational field constant, and also that number I think was missing, the radius of the Sun. So probably given those values, you can give question 5 another go. So what we'll do is assume that now that you have these equations, I mean, the back of the book goes through the answers as easily as I can. So give the question a go, and if you have any individual problems with question 5, get back to me. I hope that's okay.